We're now going to look at multiplying out brackets which include surds. This can be done in exactly the same way as if they weren't surds, which we've done with quadratics in the past. We can use FOIL or the smiley face method. I'm going to use the smiley face method here, so simply by joining everything that's going to be multiplied together with a line, and following each of those lines each of those lines represents a multiplication. So it doesn't matter which order we do this in, but 2 times 2. 2 times 4 is 8. We've used that one. Then 2 times the square root of 3 is 2 square root of 3. 4 times the square root of 3 gives us 4 square root of 3. And finally, square root of 3 times the square root of 3. Now if you times the square root by square root, and it's the same square root, you get the number, so square root of 3 times square root of 3 is 3. We then collect like terms, so 8 plus 3 gives us 11, and then we count up the number of square roots of 3, so in total here we've got 2 and 4, so we've got 6 times the square root of 3. And that's our answer in this case. What we also might be asked to do with surds is we might have a fraction which involves a surd as the denominator. So in this case, 8 over the square root of 2. And it's often easier to have the surd as a numerator, so we rationalise the denominator. That is, we get rid of the surd on the bottom. The quickest and easiest way to do that, if you've just got a single surd on the bottom, is to times the top and the bottom of the fraction by the surd, so in this case the square root of 2. So we're going to multiply the bottom of this fraction by the square root of 2, and as with a normal fraction, if you times the denominator by something, you have to times the numerator by exactly the same. Now what effect does this have? Well, at the top it gives us 8 times the square root of 2, and at the bottom, in this case, it gives us square root of 2 times the square root of 2, which is 2, which achieves our aim of getting rid of the surd at the bottom. There may well then be some simplification we can do. We've got 8 divided by 2 in this case, so that just becomes 4 square root of 2. The most complicated one of these examples is when we have a denominator that's a surd added to an ordinary number. So for example, this one here, 5 over 3 plus the square root of 3. Now again, the trick here is to multiply the top and the bottom of this fraction by the same thing. But you need to know what that is in this case. And the trick here, if we just rewrite this as it was, is to multiply the top and the bottom by a very similar expression to the expression that's on the bottom, but make the surd negative. So instead of 3 plus the square root of 3, we've got 3 subtract the square root of 3. And again, if we do that at the bottom, we need to do the same at the top. Now it's not immediately obvious why we do this, but what we need to do is we need to multiply out these brackets, just like we did over here. So if we take these brackets down here for a moment, 3 times the square root of 3, 3 add the square root of 3, 3 subtract the square root of 3. We've just taken that denominator down here to give us a bit more space. Multiply out using either the FOIL or the smiley face method, whatever method you prefer, and take this one step at a time. We have 3 times 3, which is 9. We have 3 times negative square root of 3, so we have negative 3 square root of 3. We have positive square root of 3 times positive 3, so we have plus 3 square root of 3. And finally, we have square root of 3 times the negative square root of 3, which gives us negative 3. Now the trick with this is you can see that we've got negative 3 times the square root of 3, positive 3 times the square root of 3 here. These two terms cancel, which just leaves us with 9 take away 3, which is 6. Now this bit here was all just to simplify this denominator here, which leaves us with this being replaced by just 6. So 5 times by 3 minus the square root of 3 all over 6. In some cases there might be some simplification to be done. In this case we can leave that as the answer.